Hello, I'm Saheed Lasisi, and today I'll be presenting to you Ambient Intelligence for Smarter and Sustainable Societies. And we will be examining the harmony between Internet of Things, APIs, and artificial intelligence as part of an harmony that actually brings about ambient intelligence. So I'll start with an understanding of what ambient intelligence is and the different elements of ambient intelligence. From there, I would introduce you into how ambient intelligence fits into smart and sustainable societies. We will then look at the role of APIs in ambient intelligence and smart societies. And also, we look at the role of open source in ambient intelligence. And we'll also look at different use cases of this particular technology paradigm. So we'll start with this quote by Mark Weiser in 1988. It states, "The most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they are indistinguishable from it." The idea of this is that when technologies become indistinguishable from everyday life, we take it for granted. We don't see it. It's weaved into the fabric that we wear on a daily basis, the things that we use, and we can still see the technology. That technology pervades us. The intelligence that actually enables those things to happen is called ambient intelligence, in the sense that there are so many interconnected embedded devices around us that we don't necessarily see, or we don't necessarily see how they actually work. But to some extent, they make our lives on a daily basis easier. And that is what we refer to as ambient intelligence. So, ambient intelligence in enhancing everyday life, we can actually carve out a definition of ambient intelligence around um, technologies that intuitively support us in enhancing our everyday lives without us actively interacting with those technologies, without us seeing them. We live our lives, and the technology is there to actually provide some intelligent operational efficiency for us, or proactively using our preferences to solve some problems for us as well. And that is happening on a daily basis, be it frictionless travel or frictionless empowerment of different systems across our home systems. But let's go to transforming interactions. Ambient intelligence does transform interactions in the sense that it provides an approach where we can interact with our surroundings. It also creates an element of intelligent mobility, intelligent environments around it, and improves efficiency for our environment. And lastly, ambient intelligence provides um, non-intrusive ways of actually embedding itself in our environment. The fact is that it's not in our way. We don't actually see how it works. It's it's less obvious, and as such, the magic that it creates is what makes ambient intelligence special. Because even though we're using it today, we actually don't know that we are actually using that. So ambient intelligence comes in different flavors and forms in terms of things around it. The things that we use that we can see that are part of the ambient intelligence ecosystem are things like our smartwatches, things like VR headsets, fitness trackers, remote health monitoring systems, and so on and so forth. Also, we've got mobiles, we've got tablets, we've got social networking platforms, we've got different gadgets and devices, as well as terminals that we use here and there. They make up the ambient intelligence ecosystem. In smart societies, also, what we mean by ambient intelligence could actually mean having a phone booth in public that can actually help people solve problems while they're there, or that can make them make emergency phone calls, or can make them browse the internet to actually do something in public. But also, we've got sensors at your bus stops. We've got radars at the highways, and airplanes flying everywhere. Cars become an agent of ambient intelligence as well, because we now have smart cars that can transmit and receive. They could even serve as an internet connection themselves. And then we've got electronic gadgets at home. We've got different form of virtual assistants and so on and so forth. Your TV now, your sound bars, they are all part of an ecosystem of embedded devices that actually make up the ambient intelligence environment. We also have different devices within healthcare, and in terms of healthcare, there are so many devices, sensors, utilities that actually enable ambient intelligence, and they are much more critical because some people's life depend on that. And for example, in terms of health tracking devices. You've got health tracking devices that can actually make a call on behalf of a person in case of emergencies, in case of an health critical issue, for example. And as such, the healthcare sector actually benefits a lot from ambient intelligence, and most of the ambient intelligence devices are very, very prominent within the health industry. Then we go to waste management and recycling. Smart and efficient waste management depends on ambient intelligence. It depends on tracking and efficient routing of pickup vehicles on recycling kiosks, for example, and then also collectors. We also in payments, ambient intelligence is everywhere. Payments from the smart point of sale terminal to contactless terminals, smart checkouts, endless aisles, and a manufacturing shopping floor, for example, and also through things like frictionless and barrierless travel, where we actually collect payments in different ways without the consumer actually making the effort to make the payments, or without consciously making it, but making it based on prior consent. And then in logistics, ambient intelligence pervades the logistics industry, from your Amazon delivery to your pickup stations to the warehouses themselves. They are all enabled by ambient intelligence with embedded devices that pervade the actors within this particular environment. So the fundamental elements of ambient intelligence is divided into three um, basic elements. One is ubiquitous computing, which simply means the enablement of microprocessors and computing power within the different things and fabrics that surrounds us. So from your clothes to your tables, if we are able to power them with microprocessors or power them with computing power, it simply means that they are ubiquitous. And the connection and integration of all that is what actually enables ubiquitous computing. And with ubiquitous communications, it simply means there are interactions within these embedded devices that are interconnected, that are either ad hoc or wireless in nature, which simply means they don't have to be wired. And as such, provides that ubiquity when it comes to communicating. And when it comes to ubiquitous interfaces, the interfaces of ubiquitous computing are natural and sometimes are gesture based, movement based, displacements, events that are happening within an environment, and they are personalized and they don't have to be interactive in any form. As to say, yeah, there could be voice activated also, there could be sight activated, the movement of the eyes. There are different things and different contexts within an environment that actually enables ambient intelligence. And ubiquitous interfaces actually leads us to context awareness as well, in the sense that even when an interaction happens, we still need to actually understand the context in which it happened to provide an efficient response. And that efficiency is what we'll be seeing in the next slide. So we interact with the environment using ubiquitous interfaces, in the sense that we just interact with the environment based on the things that we do on a daily basis. Thereafter, we then leave the job to the sensory organs around us. And this time around, they're not human sensory organs. They are more sensors, RFID equipments, Bluetooth low energy equipments, wireless equipments, your equipments that are actually just interacting with each other. Your telephone, your TV, your sound bar, your bike, your your fitness sensors, your lamps, for example, your bed, for example, and they all interact with each other and with some other systems to gather information about the environment that you are. Based on that environment, there are reasoning engines sitting here and there that can actually then understand the context of what is happening, and basically decide what to do next based on the information they've gathered. So certain thresholds are met, certain events have to occur based on certain things that have happened in the natural environment. And as such, some actions need to be performed. And that is the last step of ambient intelligence, where based on the sensory, the interactions, and the reasoning that we've performed, we are obliged to make an action. And that action is where we need actuators to actually, in the real life, to then act on our behalf to respond to our needs in terms of what has been sensed. So, um, what technologies are used in achieving ambient intelligence? The technologies used in achieving ambient intelligence are diverse, and they've been grouped into these elements. So, sensory technologies or sensing technologies such as sensors, RFID, Bluetooth low energy devices, microchips, and so on and so forth. We also have software agents and affective computing. Software agents are different software applications that are actually embedded within other systems and can collect information based on events and interactions within that particular system itself. We also have affective computing, that is actually a field where uh, human interactions and human affective states are actually measured, and based on that, we could actually then expose certain agents to transmit those information for their reasoning. The biometrics is one way of collecting information also, which is our face, whatever can be used to actually identify us biologically. So facial recognition, advanced computer vision uses facial recognition, for example, and sometimes also it's our gestures. Basically, like, is there something unique to a particular individual that we can combine with their facial recognition or their entire view? Apart from that, also raw biometrics is someone's fingerprint or someone's heartbeat, and so on and so forth. And then apart from that, we've got nanotechnology. So nanotechnology materials can actually be used to collect information from interacting devices or interacting elements of an environment. And microchip implants, um, while it's very related to sensing technology, so as sensors, there is a wide array of microchip implants that can be used to collect information from the physical environment that is dissimilar from sensing technologies. This is to say that some environments are equipped with microchips, with microprocessors, and as such, they can pull information and process it real time at the edge. The need for sustainability and smart society. As the urban population of the world actually skyrockets, and you can see from 1980 to 2022, there's been a steady rise of urban population, and it is projected by the UN that in 2050, 66% of the world population will be the urban population. So this brings the question: how do we cater for pressure on systems, pressure on services, and pressure on urban living areas? The unique opportunity for us to be able to address that in terms of efficiency, in terms of healthy living, and in terms of smarter living is to deploy ambient intelligence. So the recipe for creating smarter and sustainable societies is based on um, three elements that we're actually sharing it. One is efficient resource management in terms of electricity, water, um, recycling. They will become much more prominent as urban societies grow wider and wider. Improve quality of life also. So as we then have influx of population into urban communities, we also need to be able to enhance everyday living experiences for different people as they live in the spaces, as we also have a mission to efficiently manage limited resources. And then in terms of environmental impact, ambient intelligence can also provide positive impact on the environment based on the two things that we've mentioned before in terms of efficient resource management and improved quality of life. We're able to then have an environmental impact such that we actually don't destroy the environment that we inhabit due to the system pressures that we provide. And as such, whatever we've discussed here is complement to the environmental impact that we provide. And as such, we can provide positive outlooks for our environment. And to talk about this slide, so the smart urban systems. So what you can see here is different interactions and different events happening all at the same time. Every point that you see here that has been annotated is actually emitting some form of sensory information, and all this can be acted upon. You can see on one side the lamppost over there is saying it will be turned on at 7 p.m. The flight, the distance to the airport is actually 9.5 kilometers, and that has been transmitted by the radar over there. And we also have the car there saying that Alexanderplatz is actually 3.5 kilometers away. City center is 1.5 kilometers away. Different things talking to us, providing us intelligence. You could also see the weather being transmitted there, and we can see that also an event is happening in the building right in front of us. And all this information is coming to us, and we are able to act on all this disparate information that we get from a smart urban system. Now, let's talk about the IoT API and AI harmony. So, Internet of Things is the interconnection of devices seamlessly communicating and exchanging data. It is the Internet of everything. If something can connect, it is. While Internet of Things encompasses both technologies that pervade us and technologies that we can see, ambient intelligence, on the other side, focuses on the technologies that we don't see, the technologies that pervade us, and behind the scene, they're able to connect and intelligently provide us a better service or an enhanced living experience. Open APIs, not to confuse this with an open API specification. Open APIs are APIs that are publicly available and are open to everybody to consume and also to provide innovation and enhance competition, for example. So data access is what Open APIs is all about, being able to actually publicly see what an industry is doing or what a company is actually offering, and be able to access that information without any barrier. And that is what we mean by Open APIs. And ambient intelligence, on the other hand, mimics the cognitive powers of mankind and being able to solve problems and make decisions on that. And how does all this combine together to actually provide an harmony that creates ambient intelligence? On one side, Internet of Things, the advancement of Internet of Things generally means that sensory technologies, the connectivity and communication power between sensory technologies have improved. The protocols have also changed, and as such, it has actually enhanced how information is actually collected in terms of ambient intelligence. In terms of open APIs, the idea is that if APIs are open, it means different systems can interoperate, can integrate easily. People can, because these APIs are transparent, people can actually understand the risk associated with those APIs, if there are the security elements, and also time to market is also faster due to the fact that these APIs are already available. People can integrate fast, and then when things fail, also they fail fast, and we can actually move on from there. And ambient intelligence, and artificial intelligence provides us the reasoning behind the integrations and the intercommunications. When we collect the data, when we provide the data to each other and we exchange data, ambient intelligence provides us the reasoning and the finance around having to massage that data and whatever we actually intend to do with those data by using pipelines and different things in the past. Ambient intelligence today provides us a way of doing all that intelligently without having to know in advance what functions we were supposed to perform. And that is the futuristic and autonomous problem-solving skills of the world, with certain skills when it comes to domain-specific information or domain-specific expertise. The leverage is there for us to use with ambient intelligence. And then we move on to the role of APIs in ambient intelligence. APIs provides us interface transparency by providing public available interfaces for development. As I mentioned earlier, interoperability is key for us to actually enable ambient intelligence. Every embedded device must be interconnected. They must be able to then transmit their data, and within that also, we must be able to provide reasoning capabilities to collect that data and act on that data's behalf. Then standardization also helps when it comes to open APIs and ambient intelligence, due to the fact that as we promote standards, break practices within open APIs, we then ensure that all the ecosystem elements of ambient intelligence work in harmony, and nobody is actually trying to circumvent the standard. And as such, it means that the quality is enhanced, things work perfectly, and where they don't work, people understand why things don't work, because there is a level of transparency in that interoperation. And then we use open APIs to drive a common ecosystem for everybody in terms of collaboration, frameworks, and efficiency. So API style guides are a set of guidelines and best practices for designing consistent and quality APIs that are actually developer and user friendly. The idea is that when you have a style guide and people understand a style guide, it's easy to actually build systems that actually consume the style guide and use that as a basis for integrating with other ecosystem elements or devices. In the same vein, with the style guide also, it's actually also easier for interoperability for auto-generated systems where there is no developer, or there is nothing that is implementing things in real time. If we leave it to auto-generated autonomous systems, with a style guide, it's an understanding that the style guide can be deployed and used as a means of understanding how an API works. And as such, you could then use that as a tool for building other APIs or integrating with that API, because you, to some extent, understand the style of this particular API or this particular group of APIs. And it provides consistency, scalability, predictability, performance, and resource optimization, because you know what you are adhering to and what it complies to. The power of async API in enabling real-time communication. Async API enables real-time communications that is actually asynchronous and also responsive. Async APIs are event-driven by nature, and as such, this is how most ambient intelligence devices communicate in real time. And it also provides an avenue for responsiveness, for scalability when it comes to deploying, and also the flexibility of how messages are actually exchanged or received. The role of open source technologies. Open source technology provides us different advantages in terms of interoperability, in terms of community support and flexibility, in terms of common data models, open data, and transparency for cost effectiveness. People can get to market faster. People can actually open new businesses and new startup opportunities and innovate based on open source technologies. And also it ensures that different participants can come in and contribute. And mobile edge compute is one technology that actually provides a way of having intelligent devices at the edge and communicating as quick as possible. It provides it is a cloud computing technology that actually ensures that the network edge is closer to devices and their endpoints, and as such, whatever computing or processing power that is required is actually pushed to the edge so that we can reduce latency to as low as possible for different interconnected devices or embedded devices. And also, it means that there are common API specifications that drive MEC-enabled devices at the edge. And also, MEC facilitates, as we said, low latency, speed, throughput, and reliability for different devices. And also, it means that if devices can actually provide data at a lesser cost, then they become much more energy efficient. And as such, this is what brings rise to the edge of to the advent of mobile edge compute. But also, what we also have is multi-edge access compute as well, which is still MEC, and that simply means that we have multiple edges all interconnected together as a mesh at the edge itself. And then what that enables us to do is it enables us to connect multiple edge technologies and multiple edge networks together to even form a bigger mesh of interconnected devices. And that enables ambient intelligence to further provide those efficiencies and those responsive and intelligent response to society itself. And so briefly, this is the MEC Stack. The MEC Stack actually provides a common model for providing a platform to actually provide a platform, or let me say, the entire ecosystem to show. It demonstrates the entire ecosystem itself. And you would see that at the very low level, we have things and places. So those are the things in our different environments. And we have things that are sensors and actuators. Sensors collect information for observation, and then the actuators control things. The actuators are actually the part of ambient intelligence that perform the acting after reasoning has actually happened. Behind these actuators are connectivity tools and then networks, basically. And that is where we talked about MEC now, that some of these sensors have to send information, and that's ad hoc in ubiquity that we talked about. Ad hoc communications, wireless communications is empowered by this connectivity behind observation and control. And Fireware is actually an open source platform for context awareness, which is used to build ambient intelligence solutions. And then it provides a reference architecture, different reference data models, smart platforms, and so on and so forth. And then we do have different AI, what do you call it, ambient intelligence and generative AI advancement in the areas of the brain-computer interface, neural interfaces, and assistive healthcare technologies. In terms of the endless shopping floor, or let me say the endless shopping mall, it has to do with efficient onboarding systems that collect as much information and as much digital identification of a particular actor within an environment, and as such can provide frictionless shopping, manufacturing on demand, and personalized recommendations. And as such, we coined it the endless aisle. And also eye tracking device computing, beyond using hands to type and swipe and all that. There is also let me say, highly efficient eye tracking computing to enable naked computing. And using these technologies, we could actually empower disabled or impaired people in society to communicate, to perform actions for themselves, to consent to make their own decisions, even if they couldn't do that, but just with their eyes. And then seamless travel is something somebody actually comes from the airport, supplied all the information he needs to supply to the airline, and from that point, they are not actually stopped all the way, simply because we've collected so much information, and with some help from ambient intelligence, with where they are, what they're doing, and where they're going, we could actually make the travel frictionless because we have enough information about them. And we also have ambient intelligence creating different environments to adapt to user needs. And also, advancements in artificial intelligence also means that we can actually perceive and reason based on human behavior better. And we can use that to transform certain industries that improve daily life and provide benefits to society. And this leads us to the end of the talk today around ambient intelligence, APIs, IoT, and artificial intelligence. I hope you enjoyed it. Thank you. Bye.